As a tech enthusiast, I've always loved LEDs, and over the years, I've built quite a few LED projects that I really love. But I kept dreaming about something a little more portable, a display I could take anywhere. So I set out to create a simple, portable LED display platform that really just works. Today, I'll show you how to build your very own portable LED matrix display for under 20 bucks. Let's get started. To get started with this build, we'll need a few components. An 8x8 RGB LED matrix, a D1 mini microcontroller, a charge controller with a 5-volt regulator, a LiPo battery, an on-off toggle switch, and a few 3D printed parts to make up the case. You can find links to all the parts, 3D models, and code I use in the video description. The first thing we need to do is print and prep our case to house all the components. Download the 3D printable case files linked in the description and send them over to your 3D printer. Once the case is done printing, we can move on to prepping the case. I'll start by installing a heatset insert into each of the 4 holes on the top case. These will be used later to screw the top and bottom case together. You'll want to use a temperature adjustable soldering iron for this step. I've found that a temperature between 400 and 420 degrees Fahrenheit or 200 to 215 degrees Celsius works really well. I'll repeat the process for the 2 holes on the bottom case, which we'll use to hold the charge controller in place later. With the case prep done, let's work on the charge controller next. This board will allow us to safely recharge the LiPo battery we're using. Conveniently, this particular board also offers an adjustable voltage boost circuit that takes the variable battery voltage and outputs a constant 5 volts to power the rest of the components. First, I'll solder a female JST connector to the positive and negative leads of the charge controller. This makes connecting and disconnecting the battery really convenient throughout the build. While I do recommend using a set of JST connectors here, it's totally optional and you can opt to solder the battery leads directly to the charge controller instead. Now, I need to make sure that the output of the charge controller is set at 5 volts. I'll hook up my multimeter to the output terminals and adjust the variable resistor until I get a reading close to 5 volts. This doesn't have to be exact, but you want to get as close to 5 volts here as possible. I'll install 2 more wires onto the positive and negative voltage out pads. And with that, we're done with the charge controller for now. On to the heart of this project, the LED matrix. This matrix consists of 64 WS2812B LEDs. They're individually addressable, which means each pixel can be controlled independently. I'm using the 3-wire connector that came with the panel for an easy install, but if you don't have them, again, direct soldering works perfectly too. Just be sure to connect whatever wires you do use to the data in pad. There is another pad labeled data out or DO, and if you solder to that pad, your display won't work. Next up is the D1 mini microcontroller. This board will control the display's lighting patterns. With built-in Wi-Fi and Bluetooth, it's a great platform for any connected project. I'll solder wires to the 5-volt ground and D4 pins on the D1 mini. The 5-volt and ground wires will power the board, while D4 is the data output that drives the LED display. It's finally time to put everything together. First, I'll mount the LED panel to the top case using these 3D printed pins, which hold the panel in place while leaving space for the wires to pass through the back. Next, I'll firmly press on the toggle switch until it clicks into place. This switch is required since the charge controller I'm using doesn't have a switch built in. Now I'll secure the charge controller board to the bottom case using a few M2 screws and press the D1 mini into place next to it. With all the components securely in place, it's time to wire everything together. I've put together a wiring diagram you can use as a reference for this step. It covers how each component should connect together. As you complete this step, make sure all your solder joints are solid and use heat shrink tubing where needed to insulate the wires. With the wiring done, all that's left to do is connect the battery and close up the case using a few M2 screws. Finish constructing the case by pressing the 3D printed grid, diffuser, and case cover into place. With that, the hardware is done and we can move on to installing the software to bring this project to life. I'm going to walk you through two different software setups. First, we'll look at installing WLED to get some cool animations up and running quickly and easily. Second, I'll show you a slightly more advanced setup using Arduino code that notifies you when you've got a new email in your inbox. Let's dive in with the WLED setup first. Ensure that the power switch is off, then connect the D1 Mini to your computer. Head to the WLED web installer, linked in the description, and click Install. From the device list, select your D1 Mini. If you're not sure which one to pick, simply unplug and reconnect your D1 Mini. The device that reappears in the list is the one you need to choose. After selecting your device, wait for WLED to complete the installation. Then you'll be asked to enter your Wi-Fi credentials. Once your device connects successfully, click Visit Device. This is the WLED homepage, and we need to configure a few things to get the display working as we expect. Head to the top of the page and click Config, then LED Preferences. Under Hardware Setup, change the length value to 64 and the data GPIO value to the number 2. Scroll down to the bottom of the page and hit Save. Now click on 2D Configuration, then select the 2D Matrix option from the dropdown. Make sure your settings match what you see here, then click Save. If you run into any issues with the animations not displaying correctly, play around with the settings on this page until things look right. At this point, you're done. There are a ton of resources out there on how to use WLED to create your own animations and effects, so check those out if you want to play with some of WLED's more advanced features. Okay, now for the really cool stuff. Let's look at how to load up some custom Arduino code I wrote to show a Gmail icon whenever a new email arrives in my inbox. All the code and detailed written instructions are available on my GitHub page, linked in the video description. First, install and open up the Arduino IDE and load up the sketch from my GitHub repository. Before you upload the sketch, make sure you've selected the correct board and port for your D1 Mini in the Arduino IDE. Also, don't forget to update the placeholder Wi-Fi credentials and email address and password fields with your own details. The sketch needs that information to check your inbox for new emails. Hit upload and wait a few seconds for the code to write to your D1 Mini. Once the upload is complete, unplug the display and turn it on. Now, anytime you receive a new email in your inbox, the LED matrix will light up with the Gmail icon. The whole idea for this project is for it to be easily hackable. Maybe you want the display to change colors or display an appropriate icon whenever the weather changes. I would love to see what ideas you all come up with, so be sure to share your ideas and creations in the comments below. If you enjoyed this build, consider hitting the like button and be sure to subscribe for more DIY tech adventures. I have some really amazing projects in the pipeline that you will not want to miss. Until next time, see ya!